I'm Maxime Gagnebin, member of the research team at Lisk, and today I want to talk to you about token and NFT standards. So for today's talk, we will first see why we need standards and what they define, and then we will go over the two main standards for tokens that we are introducing, which are the token module and the NFT module. So let's get right into it. Why do we need standards? The reason we need standards is that if multiple chains handle and store the tokens differently, it's extremely difficult for those chains to understand each other. And so we are defining a uniform way of handling token and storing token, and this way the different chains understand what they mean. As those modules will be included in many chains in the ecosystem, we try to make the standards as light as possible. So the module that we define here only specify the minimum viable things that are needed. And so in particular, we define the state store. How are the tokens or the NFTs stored in your blockchain state? We define very few transactions that are used to exchange the tokens. And we define the necessary reducers to interact with the token store. And those reducers, maybe you have already used them if you use the SDK. They're somehow your bridge to the different modules. What it doesn't define is the custom logic. So how do you want to use the tokens? What do the tokens do? Like, is it a bike token to rent a bike, or coffee token to get some coffees, or an NFT token representing some painting? So in that regard, the custom modules are totally free to extend and use the modules for whatever needs that they have. All right, so let's dive into the token module and see exactly what will be available in a future version of the SDK for sidechain developers. The first thing that we need to address is token identification. When you only have one blockchain, token identification is a trivial question because you know exactly which token you are talking about. On the Lisk chain, you are talking about the Lisk token. However, once you try to connect multiple blockchains, you need to know which token is used and which token is exchanged. And for this, we introduce the token ID. And the token ID is made of two parts. And the first part is the chain ID. This ID is given by the Interoperability module, and it identifies the native chain of the token. So where was the token created? Secondly, we also have a local ID, which can be used to have multiple types of token on the same chain. So on one chain, you can have multiple local IDs, which represent different tokens. As an example, the Lisk token will be identified by 10. So the chain ID of the main chain is 1, and the local ID will be 0 because the Lisk token is the first and only token of the Lisk main chain. But you could have some other chain, let's say a bike chain, where you have a governance token, chain ID of the bike chain is 3, local ID 0, and some utility token, the same chain ID, but their local ID 1. All right, and those tokens are stored in the token store in the state, and we separate the state into three main parts, which are the user store. So this is the same as the accounts now on the Lisk main chain. Which address has how many tokens of which kind? We have an escrow store that Andreas mentioned and that we will talk a bit more about in the following slides. And lastly, we have a supply store. The supply store is just an informational store which tells you how many tokens exist in the whole ecosystem of this type. All right, so let's see a bit more about the escrow store and why it is needed. Let's say that you have a gold chain connected to the ecosystem and a research chain. And we have a user, Alice, who owns 5 gold tokens and wants to send 3 of them to the research chain. The basic way of doing this would just be to say, okay, we subtract the 3 gold tokens from Alice's account on the gold chain, and we credit them on the research chain. And this seems fairly natural to do. The problem, if you do this, is that in an ecosystem of blockchains, we could have one malicious blockchain connecting to the ecosystem and trying to generate fake gold tokens to send back to the gold chain, and then fool everybody into thinking there are more gold tokens than what actually exists. And if we don't have any additional information, then the gold tokens coming from the malicious chain or from the research chain are very difficult to distinguish. The gold tokens coming from the gold chain, those are easy to distinguish because the gold chain is the native token of, sorry, the native chain of the gold token. So we always assume that the native chain is honest in this regard. The solution for this is quite easy. The gold chain just needs to store where the different tokens have gone. So if the token went to the research chain, then you can see that the 3 gold tokens are escrowed for the research chain. This doesn't really change much the scalability issues because once the gold tokens are on the research chain, they can be exchanged between any users on the research chain. This will not affect the gold chain. The gold chain only knows the global state of where the gold tokens are. But now, if the malicious chain tries to send back gold tokens, this will be detected on the gold chain, and the gold chain will close the channel to this malicious chain, saying, no, now we don't interact with you anymore. So in terms of properties, this allows every chain to maintain the total supply of tokens, and it prevents one bad actor in the ecosystem to somehow pollute the whole thing with malicious tokens. In an ecosystem like the one we're creating for Lisk, it's impossible to control the code of each individual chain. But the aim is that if you have one chain which misbehaves, then that misbehavior cannot be propagated to honest chains. And so this is done with these escrow accounts. It has the slight drawback that now you have to send tokens to and from your native chains in order to always maintain those escrows and know where your tokens are in the ecosystem. All right, now we have all those tokens flying around, and maybe your chain is an exchange and you're super happy to receive all those tokens, but maybe you want your chain to be a bit more clean and you don't want all those tokens flying around. And for this, we also introduce a solution. So we introduce this notion of supported tokens. And when the tokens are transferred from one chain to the next, of course, they are escrowed. But once they reach their receiving chain, the token module will ask the question, is that token supported on this receiving chain? If yes, then the tokens are credited, no problem. And if no, the tokens are just sent back and the transaction can be reverted on the gold chain. All right, so that was it for the store. Now, let's move to transactions. We are defining 2 transactions for the token module. The transfer transaction, very well known, moves token from one address to the next on one blockchain. And the cross-chain transfer, exactly the same, except from one chain to another chain. This is quite easy, and the next slide will be very interesting for developers, and those are the reducers. So what interfaces do you have to interact with the token module? Well, the first 2 are the mint and the burn reducers, which are used to create and destroy tokens. Good example of this is the block reward. So the mint reducer will be used on the Lisk main chain every time we create a new block. And an example for the burn reducer is, for example, the min fee in the main chain. So on the main chain, we will burn the minimum part of the fee for each transaction. Next reducers, really interesting, the lock and unlock. This prevents a token from being transferred from one account to the next, but it does not change the ownership of the token. And that's a very useful feature. For example, we use it for voting on the main chain. So when you stake tokens, those tokens stay your property, they stay in your account, but they are locked, and so you cannot move them around, or you cannot use them for another interaction. And we expect that many custom interactions will use those lock and unlock tokens to use tokens in that regard. Okay. And lastly, we have two reducers which mimic the transactions. So a transfer reducer and a cross-chain transfer reducer, which maybe in your transaction, you have some complex logic and a transfer. And so for this, you can use this reducer. And that's it. As I told you, the main reducers are really lightweight, but they are basically all the interaction you would need with the token module. Then everything else will be done in custom logic. Now, a small word about the Lisk token, the LSK token. This token is part of the token module, so it can be interacted with in the same way as any other token with the reducers that we are introducing here. As the Lisk ecosystem is done where you always send your cross-chain message to the main chain is always able to maintain the escrow account for the LSK token, and so this token can be sent from one chain to the next without any hassle. It's also the token used for the message fees. And lastly, I told you that we have this supported token function on each chain. Well, the LSK token will be accepted by default on every chain. OK, so that's it for the token module. Now let's move on to the NFT module. And first, let's see the differences between an NFT and a fungible token. The main difference is that NFTs have a unique identifier. So if we check the NFT ID, it is made up of the chain ID, a collection, which is the same thing as the local ID for fungible tokens. So those two together, they define somehow the big picture of the token. But then each individual token has an index. For example, if you have a chain for arts, then you could have a Picasso token, chain ID 12, collection 1, and a Ricotone token, chain ID 12, collection 2. And then every artwork by Ricotone will get a new index. And second difference, NFTs have an attributes property. And this is a property that can be used by custom modules to store basically everything or anything that is linked to this NFT. So here I have the example of a Ricotone NFT. It's a parrot. And in the attributes, we could have the name, parrot, and the style, pixel. And the whole handling of these attributes is done by custom logic. All right, and let's see a small example of an NFT going in the network and how the attributes are maintained in that regard. Oh, sorry. No, first we're going to just have a look at the store for NFT. And it's very similar to the store for tokens. We have an NFT store where each NFT is stored with the owner, if it's locked or not, and its attributes. We have a user store, which is used to do a reverse lookup on NFTs. So if you want to have all the NFTs linked to a given address, you can use this store. And we have a collection store, which is similar to the supply store for fungible tokens, where we have the maximal index used by a given collection. So now let's go to this attributes example I was talking about. Let's say we have our parrot, and we want to send the parrot from the art chain to the research chain. So first thing, will the parrot be supported on the research chain? And for this, we just ask, is this collection supported there? Let's say it is, and the parrot is given to Alice on the research chain. The thing is that the research chain doesn't know anything about art, and so it doesn't understand what the attributes are about. And so Alice, if the research chain allows it, could maybe modify the attributes of the parrot. And so now the parrot has fake attributes. It says eagle and oil, like an oil painting. And Alice could try and fool people into believing that this is an oil painting. Of course, anybody could check the art chain to see that the attributes have been stored over there, and it's actually not an oil painting. But we also have the capability that when the parrot is going back to the art chain, those two sets of attributes will be compared one to the other. So we will check, like, this eagle oil, is it actually compatible for the parrot? And the art chain will say, no, it is not. The parrot should be parrot pixel. And so it will restore the parrot with the correct attributes. In that regard, in your custom logic, you can define attributes that are modified on other chains. So maybe when your NFT comes back to your native chain, you actually accept the changes. You don't need to always revert them. But this is defined by custom logic when the NFT is returned to the native chain. All right. And so to wrap up NFTs, we also have two transactions, which are the transfer transaction and the cross-chain transfer transaction. They behave exactly similarly as the one for fungible tokens. And for the reducers, we have all the same reducers, but one additional one used to set the attributes of the NFT. And so in your custom logic, you can call this reducer to set new attributes in the NFT. All right, so to finish my talk, I'm just going to show you this picture of a potential Lisk ecosystem with different tokens and NFTs. You can see that on the main chain, we only have LSK tokens. You can also see that if you add up every token in a user account and every token in an escrow account, you get the supply total. And yeah, and that's it. Thank you very much.